Draw the moment diagrams for the frame. Assume the frame is pin connected at A, B, and C, and fixed connected at E and D. To begin, first of all, let's cut this frame into pieces so that we could solve them individually. We're going to start with BC section. So let's draw the free body diagram. At B, we have external reaction from member BA. Then we have our unknown force at member CY and unknown force at CX. And we have external reaction force of 30 kN. Our CX is going to be 0 kilonewton because there isn't any other horizontal force we can see. Now, to find our solution for BY, we can take moment about the point C and have a clockwise BY. Counterclockwise 30 kilonewton. All for BY, we get a solution at 75 kilonewton. Now we can run the forces in Y fraction to solve for CY. And we get CY as positive 45 kilonewton. Now we can start solving for our next section, which is CD. CD we have CY, which was 45, we just found. CX we said it's 0. And then at dy and dx is unknown. And then there is a moment d. So our dx in this case is going to be 0 because we have cx as 0. And then our dy is going to be 45 kilonewton positive. To kind of find our moment, we just need to take moment about point D. And moment D. Then we have clockwise 45 kilonewton times 2 equals to 0. Moment at D comes up to be 90 kilonewton meter. Now we can draw the free body diagram for member D uniform load. We're going to convert it. It's going to become 6 times 2, 12 kilonewton. And then we have already found our dy, which is 45 kilonewton. Dx we said it's 0. And in here we have, because we have counterclockwise and the CD, so we're going to have clockwise on this. Alright, now let's find the moment of, or the force on EX, and EX is going to be simply 12 kilonewton. And so is our EY. EY is going to be negative, but if we switch our sign, it'll become positive 45 kilonewton. And now we can take moment about the point E to find our moment. Counterclockwise 12, 3 meters away, equals to 0, and the clockwise at moment T, which we have as 90, equals to 0. So for moment E, we get a solution as negative 54 kilonewton meters. This means we need to switch our sign and make it clockwise. So our moment is, never mind. I took a wrong sign here. Moment is, so we have counterclockwise moment E, counterclockwise 12 kilonewton, and clockwise moment D. And so for it, we get a solution as 54 kilonewton times meter counterclockwise. That's good. Alright, now that we have this value, we don't have to find any value for AB member because only force that would be meaningful there is vertical reaction force, and we are not gonna draw any diagrams with it, so it's not useful in our case. Now let's begin drawing moment diagram for B to D. We're gonna start with the shear diagram. So we begin with negative 30K. Or I mean negative 30 kilonewton. Then we move to right for 3 meters in a straight line. And then we got positive bump of 75. That means we go up to 45, positive, and then we continue for 2 meters, and then we got the bump downwards at C to 0. And then actually we can have it as I've drawn it, or to make our life easier and not be drawing more individual shear moment diagrams, what I'm going to do is combine CD as well in this diagram. And what it will do is, like, we're going to continue for 2 more meters and then come down to 0 with the bump from dy instead of the cy. Now we can draw our moment diagram. So our moment initially will start from 0, and then we have this area on the shear which is negative, so that means we're going to go downwards, and it's 30 times 3, which is 90. So we're going to go down for 3 meters till we reach negative 90, and this will be our first order curve. And then our next area is this whole area, which is going to be 45 times 4, which is going to be 180. So we're going to go for 4 meters, or we're going to travel for 4 meters, and we're going to go positive 90. And then from 90, we're going to have our moment, which we said is going to be counterclockwise at D. So this means we can get back to 0 with the help of that. And as for our intersection will happen where we had CY earlier. In the shear diagram, I'm going to highlight it in red. So this area will be at 5 meters. Now we can draw the shear moment diagram for member DE. So we're going to begin with our uniform distributed load, which begins at 0 and go down all the way till 6 meters and becomes negative 12. And then EX bump it down back to 0. And that also tells us that our equation was correct. Now for our moment diagram, we begin at 90 because of the moment D. And then we have this negative area, which is going to be 12 times 3, which is 36. So at 6 meters mark, we're going to have second degree curve concaving downward, second degree curve or second order curve, and then our moment of 54 will bump it down back.